Day 427 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3307. Find the kth character in string game 2. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Alice and Bob are playing a game. Initially, Alice has a string word which equals A. You are given a positive integer k. You are also given an integer array operations where operations of I represents the type of the ith operation. Now Bob will ask Alice to perform all operations in sequence. If operations I equals 0, append a copy of word to itself. If operations of I equals 1, generate a new string by changing each character in word to its next character in the English alphabet and append it to the original word. For example, performing the operation on C generates CD, and performing the operation on ZB generates ZBAC. Return the value of the kth character in word after performing all operations. Note that the character Z can be changed to A in the second type of operation. All right, y'all. So that sounds pretty complicated, right? So let's go ahead and take a look at these examples just to make sure that you're doing this problem correctly, or that we are doing this problem correctly. And also, before we get into the examples, I want y'all to, if you didn't complete yesterday's problem, which was find the kth character in string game 1, which is the first part of this problem, I suggest you go check that out. It's an easy question and it will get you ready and more prepared to answer this question. Now let's get into these examples. So in example 1, we have the input k equals 5, operations equals an array of integers 0, 0, 0. The output is A. Explanation says, initially word equals A. Alice performs 3 operations as follows. Appends A to A, word becomes AA. Appends AA to AA, word becomes AAAA. And appends AAAA to AAAA, word becomes AAAAAA and A. So just in case that didn't make sense, let's go ahead and break this down one step further. So we have our input k equals 5, operations equals an array of integers 0, 0, 0. It says right here, if operations is equal to 0, we're going to append a copy of word to itself. So the word, we're always starting with A, right? It says Alice has a string word A. We're always going to start with the string word A. So with this operation, we just append a copy of word to itself, right? So we come right here, 0. So we append a copy of the word to itself. That's how we append A to A, and that's how we're left with AA. Then we have another 0, so we have to perform the same operation and append a copy of that word to itself. So we have AA, which means we need to append AA to itself. So we append AA to AA, and that becomes AAAA. So now we have to keep going because we need at least 5 characters, right? Because k equals 5, so we need to find the 5th character, whatever the 5th character is. So that's why it's going to take another operation, because right here we only have 4 characters. We need at least 5 to figure out what the 5th character is, because k equals 5. Now if k equaled 1 or 2 or 3 or 4, then we wouldn't need any more operations. But since k equals 5, we need to perform one more operation. So we have another 0 in operations, and right now we have AAAA, which means we need to append AAAA to itself, meaning we need to append AAAA to AAAA, and that's when it becomes AAAAAAAA, etc., so on, right? And now that we have at least 5 characters, we could come over 1, 2, 3, 4, 5, and I'm sure as you guys guessed, the 5th character is A, so our output is A. Now let's take a look at example 2, where they give us different types of operations, and which will allow us to have different types of characters. So in example 2, this time the input k equals 10, operations equals an array of integers 0, 1, 0, 1. The output is B. So initially, we start with word equals A. Again, Alice performs the 4 operations as follows. So first we have a 0. So that means we're going to append A to A, and it becomes AA. Because once again, 0, we append a copy of word to itself. Next, when operations equals 1, we generate a new string by changing each character in word to its next character in the English alphabet and append it to the original word. Similar to when I was talking about earlier, string game 1, that was the only operation they gave us, right? Which is this one operation where we had to generate a new string by changing each character in word to its next character. So that's why I suggest you check out yesterday's problem, which is find the kth character in string game 1. So now we have operation 1, which means we have to find we have to generate a new string by changing each character in word to the next character in the English alphabet and append it to the original word. So right now we went to 0. We started at 0. We went and we appended A to A. Now we have AA. Now we get a 1, right? So what comes after A and A? B. So that's where this BB comes from. So now we append BB to AA because, once again, we're generating a new string by changing each character in word to its next character in the English alphabet and appending it to the original word. So once again, the next character in the English alphabet after AA would be after A would be this B, and then we have 2 A's. So after this A would be this B. So now we have 2 B's and 2 A's. We need to append the 2 B's to the 2 A's, and now we have this as our string, AA, BB. Why? Because B comes after A in the English alphabet. So now we are left with this AABB, and we're on our third operation, 0. Our third operation is 0. So once again, we just append a copy of word to itself. So since we have AABB, we append AABB to AABB, and now we have AABB. Boom. Now we have our final operation remember, K equals 10. So we have one more operation and we have to get at least 10 characters. As of right now, we only have 1, 2, 3, 4, 5, 6, 7 characters. So we need at least 10 characters so we can get the kth character, and we have one more operation. So we're performing our last operation on this string right here. So every string or every character in this, we're going to get the next character and append it. So for this, you can see we append B. This would be B, B, C, C, B, B, C, C. Once again, we're just doing all of the characters that come next in the English alphabet. And yeah, that leaves us with this B, B, C, C, B, B, C, C. And we need append this to this string that we had originally, right? Which is right here. So we append this to this, and then word becomes this right here. Now, after we have this, we just need to find the kth character, which in this case, the kth character is 10. So we come over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Boom. This B right here is the 10th character, and that's why our output is B, and that's how we got it. So, with all that being said, y'all, I hope that made sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. The solution is way easier to understand than the question, I believe. So let's get into it. Now, first, we're going to start with index I, and we're going to set it to K, right, in a 1 base index of the target character. So we just declare a variable called I and set that equal to K, just like that. Now we need to count how many transform operations have been applied on the path to the kth character. So we declare a variable called transform, and we'll set that equal to 0. Boom. Now we need to trace backwards from position I to position 1 in a binary tree-like structure. So we can say while I is greater than 1, we can open up our brackets, and we're going to find the highest power of 2 less than I minus 1. This is going to give us the level in the binary expansion tree where the current character came from. So to do that, we're going to say let n equal floor open up the parentheses, log 2, open up the parentheses, double, open up the parentheses, I minus 1, just like that. Then we need to subtract 2 to the nth power to move to the parent node in the tree. So we're going to say I minus equals int, open up the parentheses, pal, open up the parentheses, 2.0, comma n. Boom. Then if the operation at level n was a transformation of value 1, we're going to increment the transformation count. So we're going to say if operations square bracket int parentheses n equals 1, then we're going to open up the brackets and we're going to say transforms or transform plus equals 1, just like that. And now we need to convert the total number of transformations into a character. A is Unicode scalar 97, and adding transformer mod 26 wraps around the alphabet. So we just come right here and we say return character, open up the parentheses, Unicode scalar, open up the parentheses, 2 parentheses, we're going to say transform mod 26. Come outside of that parentheses, this first one right here, we're going to say plus 97. Come outside that parentheses, but still inside the last parentheses, and we're going to force unwrap it with the exclamation point like that. Now let's go ahead and give this a run before we submit it. Make sure it works. That's all the code. Okay, can I find, oh, sorry, y'all. This should be operations with the S. Let's give it a run again. See if that does the trick. Let's see, and it's accepted, y'all. So let's go ahead and submit it and make sure it's still accepted after we submit it. Let's see. Ooh, look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. Those are the numbers I like to see, y'all. So with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.